to the class of Technomaths. So today we'll be taking this question where two blocks are kept upon each other, okay, and the arrangement is like this, okay. In the figure, we need to determine this force F, right? A force F is needed to pull out the 6 kg of block, okay, and the block which is on the top is of 2 kg, right? Now we need to find the that if we need to find the force F needed to pull out the 6 kg block with an acceleration of 1.50 meter per second square. So that means this force is applied, and after that an additional acceleration will be applied on it, okay. So just to move out this 6 kg of block with an acceleration of 1.5 meter per second square, right? This is the data given to you. And if the coefficient of friction between the surfaces, right, is given to you as 0.40, right? Now we need to find the force applied, right? Here into this question you can see this 2 kg of mass is tied with a string, okay. So this will not going to move along with the mass 6 kg of block, right? So when you draw the free body diagram of the 2 kg and the 6 kg blocks, the 2 kg block and 6 kg blocks, if you draw the free body diagram, then the 2 kg then this 2 kg of block, when this force will be applied and pulled on the 6 kg block is pulled, then a frictional force will be applied on it, okay, just opposite to it, okay. So when the frictional force is applied on it, then we can say that on the 6 kg the frictional force will be equal to this let us say this is a tension T applied into the string, and the forces which are acting along the opposite side is mu n, that is mu times 2 mu into 2, right? Now when you see the 6 kg block, okay, when you saw the 6 kg block, the forces which are acting on it is this F, which is already given to you into the question. And when this is moving towards in the force of direction, and ma will be generated, ma, that is 6a, right? And additionally the total 2 6 plus 2 8 kg, 8 kg will be applied. So a friction of force which is acting opposite to the direction of motion will be applied over here, and that 6 plus 2 total 8 kg, 2 plus 6 that is 8 kg. So you can see mu times n, normal reaction, and n is mu is given to you as 0.40, 0.40 into n is nothing but 6 plus 2, that is 8, 8 into g, mg, right? So this 8g will be applied. Apart from this, this 2 kg of this 2 kg block is also exhibiting some frictional force, and on the free body diagram of this 6 kg of block you can see this will give you this mu into 2 into g, mu into n, right? So what is the force? You can see the force is applied into the right hand side. So net force, the block will be 6 kg block is moving right side, right? So we can say that this F minus mu into 2g, this frictional force by this small mass 2 kg which is on the top, minus this 0.40 into 8g, that is this is the total due to the total combination, this one 0.4, that is let me write instead of 0.4 mu minus mu into 8g, this will give you ma, m is 6, right? So this will give you 6 into a, right? And here the value of a is also given to you at 1.5 meter per second square, right? So what we can do, the value of F is calculated, that mu times 2g, mu times 8g. So you can write mu times mu into 10 into g will be going to the RHS plus 6a. So 6 into a, put the value of a as 1.5. 1.5. So this will give you mu, put up the value of mu at 0.4. 0.4 into 10 into 9.8, right? Plus 1.5 into 6 is nothing but 9, right? Then just solve it. 10 into zero point 0.4 is 4. So 4 into 9.8 plus 9. So this will give you, all this unit is in Newton because this is force. 4 into 9.8. 4 into 8, 32. 39.2 plus 39.2 plus 9, decimal was left. So this will give you 39 plus 9, that is 48. So 48.2 Newton of force need to be applied on the 6 kg block. This much of force need to be applied into the onto the 6 kg block, then only this block will be moving with an acceleration of 1.5 meter per second square. And it's also given that the friction, the coefficient of friction between the surfaces is 0.40. So that is applied, that friction is applied at this surface between the point of contact between the two blocks, right? So here the mu coefficient of friction is applied, and this block is also resting on the ground. So here also a coefficient of friction will be coming into picture, right? So here you can see that considering all this, we have calculated that the effective force, the unit of the force, the magnitude of the force should be 48.2 Newton. Then only this block will be moving with an acceleration of 1.5 meter per second square. Okay, so we just see the free body diagram of this 6 Newton, 6 kg block. Here F will be acting into the right hand side as given to you into the question, and let us say this is moving with an acceleration of 1.5 meter per second square. So MA will be acting into the right hand side. Okay, and here due to the 2 kg block, mu times 2g will be acting into the left hand side, and due to the entire weight of 8 kg, 2 plus 6, 8 kg, this mu times n will be acting into the left hand side. So mu times 2g and mu times 8g, so this will add up, and mu times 10g will be acting, mu times 10g plus 6 times a. Put up the value of a as 1.5 meter per second square and solve, putting the value of g as 9.8, and solve to get the value of 48.2 Newton as the value of the magnitude of the force which is required to impart an acceleration of 1.5 meter per second square to the 6 kg block, right? So F is equal to 48.2 Newton, and this is our answer, students. Thank you so much for watching. Let me come up with separate question again into the separate live session. Thank you so much. For any query, you can put up into the comment box. Thank you so much. Bye bye. Take care. Be connected. See you.